Okay, welcome everyone to this week's compiler architecture meeting. So today actually I don't have anything to present or anything like that. I was hoping that we could have a discussion around a topic that has come up recently with regards to some initialization work that's happening in the compiler technology. So I would think that a lot of the discussion that maybe we'll have today isn't necessarily around the compiler in particular, but more into OMR and how the different components of OMR are initialized. So just for a bit of background, the compiler technology recently created a dependence on the port library in OMR. And there's a number of advantages for doing that. There's a fairly good discussion on the issues that we created and that we followed to do that work. And we were able to actually make that dependence. The next sort of step in that for that work is to actually initialize the port library, initialize the JIT technology in sort of the right places. While we can hack something together, that isn't necessarily the cleanest way of doing it. And in fact, there already is in the OMR startup files. There are methods, OMR initialize VM and OMR shutdown VM, that already take care of doing the initialization for the components that are actually enabled. And initial thinking was that the compiler technology should just be part of that, right? And so we started looking into what would be required for us to do that. And it turns out it was a little bit more difficult than what we had expected. And I think we wanted to talk through some of those issues today, and maybe to come to some kind of an agreement or a direction forward on how we want to approach the initialization problem in OMR. So in terms of one of the issues that we had seen, so there's at least a couple of things that we should probably start to talk about. But one is that there seems to be a requirement in OMR initialize VM that there's a number of other components that are required as part of the initialization process. And if we're sort of looking at maybe the philosophy of OMR, where you can sort of pick and choose the components that you want and only build in those components, it doesn't seem right that there's a dependence, for example, on the OMR on Health Center during the initialization process for something that doesn't need it, or for a component that doesn't want it or not. So the thinking there is that perhaps the steps that are in that initialization need to be more guarded for the different components that are enabled in the build that you have. So not just being enabled, but actually present as well. So perhaps we need more build flags around the different components to allow that. And I guess the question then comes up is whether or not the way that we have architected OMR at the moment allows us to do that easily. So maybe we'll just pause there and see if anyone has any particular thoughts on that, especially those that have got more detailed knowledge of the initialization strategy that we have currently. Do we think we can actually add more guards to that function? Would that be feasible?
Daryl? Yeah, that's exactly. It's just missing some wrapping. So when that code was added, it was added prematurely. There's 3 RAS things that are started up and shut down that aren't under flags, and those should definitely just be wrapped with the right flags. It's on the list of to-dos.
Okay. Are there already built flags for those pieces?
Yes, there are.
Okay. That should be easy to do then. Okay. So, okay, that answers, I think that would solve a lot of problems for sure. So with that, I think that we could actually insert at least the initialization. We'll have to work on standardizing the interface for initializing the compiler technology. We'll have to create. I mean, there already is an initialize JIT function, extern function that gets called, but we'll probably have to document that a lot better than it currently is. So we'll do that. The other thing that's going to come up here as well is what the requirements are for the initialization function. So the OMR initialize VM. So right now it takes 4 parameters, an OMR VM struct, I think an OMR thread struct, and then language VM and a language VM thread. One of the challenges that we ran into was the fact that in the case of us initializing JIT Builder was that those structures don't necessarily exist. Well, not necessarily. They don't exist for JIT Builder at the moment. So the question is...
Can I interrupt for a second?
Oh, absolutely.
The language VM and language thread, I'll give that language thread is probably something that a lot of languages may not have because they may be a single thread at runtime. Mm-hmm. Language VM is almost certainly something in everything you talk about. Mm-hmm. OMR VM thread and OMR VM thread slot, those are 2 things we have to pass in, but I believe we already actually handle the other 2 things being null if they need to be, if you don't have any struct. But just the background about OMR VM is kind of where everything is hung together that the components can use. Like right now, I know the JIT and JIT Builder aren't plugged into the startup APIs and things, but as they plug in, I think it's a great opportunity for some of the global structures that the JIT Builder uses and the compiler technology in general use to actually move into the OMR VM struct or like be held off of that, so it's actually easy to get to it, and then everyone has a common way to go and get it. Again, OMR VM thread is per thread data, which in a lot of runtimes, I believe the compiler technology will definitely need some per thread data. JIT Builder itself, again, if you're in a runtime that doesn't have anything, then maybe there's not much per thread data there. But if there is more threads in a given runtime, again, I assume the compiler technology for sure, and JIT Builder most likely will also have per thread data, which this is kind of like the idea of how that's all hung together in OMR.
Okay. Yeah, I think that's kind of where this discussion was going to go, is to sort of what do we want the consumers of OMR to actually provide? So I mean, at the moment, I don't think JIT Builder does use an OMR VM, but perhaps it should, right? And if it will, what components of that structure do we want? Like, what is the minimum sort of set of things we need to have set in an OMR VM for a consuming language runtime? I think right now that structure is somewhat minimal, but I think we need to have an understanding of what all the different fields are in there and what it actually means for a runtime. Did you want to say something? Oh.
I don't know. Is this microphone here?
Yeah.
Okay, so like from my perspective, it almost seems like the VM startup and shutdown APIs, therefore bringing up an entire language VM runtime. But JIT Builder isn't really a part of that story because it's just a general compiler framework. So maybe like the VM startup and shutdown APIs should be bringing up a compiler component, but maybe that component isn't JIT Builder. That's the compiler component that the language has built, which would be something else. So JIT Builder wouldn't even really factor into the story of like how of this like startup API. It's just a different thing.
I sort of agree with that, except for in a lot of runtimes, I think JIT Builder will be the compiler technology that is used. So JIT Builder is kind of different right now from a lot of parts of OMR, sort of, but not really. Something like to port and thread library, they could easily be used by a runtime just by themselves. But if the runtime wants to consume more than one component from OMR, then these startup and shutdown APIs are my belief of how the runtime should then be consuming OMR. If you want a single component, and that component supports being brought up and shut down on its own, like JIT-Builder, the current way it's packaged, then I feel any runtime is free to go consume it that way. But if you want the opportunity to use port, thread, and now that JIT-Builder sort of has a dependency on port and thread, and you say you want to use the GC and RAS and these other features, these are the APIs to sort of get in there and bring up the entire OMR for a runtime. I hope that sort of made some sense.
Yeah.
Yep.
Well, I'm hearing kind of two use cases here that I think are valid for JIT-Builder. One is, which we kind of talked about before, is the sort of just native acceleration library, which is not really using JIT-Builder as a JIT in a runtime per se. It's just being used as a library to generate native code. And in that case, it may not make as much sense for JIT-Builder to slot into the initialization process of the VM. But when it's being used as a JIT in a runtime, then it does make sense for JIT-Builder to be slotting in there. So I think having the ability for JIT-Builder to be a part of the initialization process, but also have a sort of standalone use case supported as well, I think is where I'd like to see that.
So what's the drawback, though, of actually still having a central function that does that in both cases? It's really which components are enabled, and or is it parameters
so
to the...
The question is what is that? What is the value of that in the... like, you can hide whatever you want behind initialized JIT, right? I mean, initialized JIT takes no parameters. It's just a call. So, you know, in principle, initialized JIT could create an OMR VM structure or a language VM structure of its own. It could create a language VM thread. It could do all kinds of stuff under the covers in order to match the API that the OMR initialized VM stuff is supporting. But I wanted to be careful about dragging too much stuff into the JIT-Builder library, because I'm actually in the process of trying to make it smaller and strip stuff out, as opposed to, you know, making it more all-encompassing. But I do want JIT-Builder to be able to slot into that process so that it can work properly as a JIT within a full-fledged runtime. So I mean, if we can make it work in such a way that, you know, I don't have to I can create an empty struct, or I can pass a null or whatever, then that's fine. But if it's, you know, I guess the other mild concern I have is that right now our model for building everything outside of the compiler is you specify a bunch of configure flags, and then you build it, and you get a static library that has the thing in it, and then you link against that. So if we're going to have a bunch of different tests, we're also going to have a bunch of different builds to rebuild. You know, here's the build of OMR that we did in order to test JIT-Builder. Here's the build of OMR that we did in order to test the test compiler. Here's the build of OMR that we did to test everything else in OMR. Unless we can figure out some other way of, you know, solving those different requirements, I guess, in one build.
I think that with regards to like having one build that can build multiple compiler components versus just building different components in different builds, I think that the direction that the direction that we took in the rest of OMR is that you build one particular thing per build, and I think that that makes sense for the compiler as well, and just having multiple builds, one for the test compiler, one for the JIT-Builder, and whatever.
Except that JIT-Builder is a different compiler than the test compiler than the base compiler. Right?
Yeah.
The way you build a compiler is you take a bunch of stuff and you plug it in, and it gets sprayed throughout the whole compiler.
Yeah.
Right? So you get a different type of resolve method, you get a different type of simple references, you get different types of and potentially anything. Right? So there's no kind of core, I mean, there are for any one compiler, but because of the way extensible classes work, you can basically extend any of them and incorporate that into the base functionality quite tightly, right?
So then, I guess the question would be, like, which compiler does the VM bring up? Yeah, and the other thing that I'm thinking about...
Just to make my other point clear, so if you're going to compile the file that has OMR initialized VM in it, when you're running a build that's going to have a GC and RAS and profiling and all the other support that's in, tracing and all the other stuff that's in there, you're going to want all that stuff pound-if-deft in.
Yep.
Right? When you build a JIT builder library, you kind of don't want all that stuff pound-if-deft in because it's not really useful for JIT builder.
Yeah.
But at that point, I don't think you would be using those VM startup and shutdown APIs if you're going to be doing a lot of those other. If you're using the second way you talked about JIT builder, Mark.
Yeah.
I feel like that in that case you would probably just call initialize JIT and have only compiled up because you just want JIT builder. So I think you'd have turned off basically almost all the other compiler flags. Wrong word, not compiler. Build flags. I think you would have turned off like GC, RAS, whatever our core library is called that has this startup and shutdown API that Rob is actually just working on renaming and cleaning up right now. I think you would turn off all of those, and at that point you would just get a libJIT builder in the end. And if that's got a requirement on port and thread, I guess you need port and thread as well.
Right.
But at that point, if you want to bring up just JIT builder, I think you would want to probably at that point just start up the port library and start up JIT builder using initialize JIT yourself directly, because you're not really using it as a runtime. You're using it as some other just JIT library or something.
Right. So just to be clear, that means we're making JIT builder a different. When you use JIT builder in that scenario, that becomes a completely different build of OMR. The full OMR at that point, in principle, right?
Yeah.
Or maybe just one artifact that you can rip out of a full build, like a JIT builder library.
So you'd say you might build two different types of initialization
or some
paths through that. Which would be for the JIT builder standalone, one which would be for a full runtime.
I'm thinking that maybe the thing that makes the most sense is to have JIT builder have its own complete set of initialization APIs and keep those maintained, and then layer the VM or like the runtime initialization on top of that as like a separate library. So when you do a full build of OMR, you can still consume JIT builder as standalone, but you can also use it using like the mega startup API.
But wouldn't there still be some shared infrastructure under, like you wouldn't want JIT builder to know how to initialize the port library?
Well,
the thread library.
So the JIT builder startup APIs would take it like a port library pointer, and then it would be up to the application to bring up the port, bring up thread, pass it into JIT builder as part of startup.
That I don't like. I mean, right now JIT builder is very simple to use. All initialize JIT, doesn't worry about anything else. That's part of its attraction, I think, anyway.
Mm-hmm.
Right? Prefer not to say, okay, now you have to do X, Y, Z, blah, 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 blah. And every time we want something new, we have to update what the initialization sequence is that you have to do. I'd rather hide that behind initialize JIT than have, like, if you need a port library, if JIT builder needs a port library, JIT builder should just initialize that as part of its initialization.
Okay. Well, the other...
Or find one that's already initialized.
If one's there, yes.
That's what you're trying to get. You're trying to not have 5.
Yeah.
And you want them configured the same way as the first person who did the initialize did it right, in theory, and then anyone else has to consume that one.
But I guess the model I was thinking of was, so a consumer of JIT builder would call initialize JIT, which would then dive down into whatever the OMR initialization process is configured appropriately for how JIT builder wants to be. And then if someone were doing the full-on runtime initialization thing, they would just call initialize VM themselves appropriately. And maybe, I don't know, then how does JIT builder work in that context? Yeah, you're right. It kind of has to figure out.
It has to know that it's either...
There's one already,
right.
So use that one.
Yeah. But I think this is just another. So I think we're just trying to shoehorn our current API and the current initialized JIT API together or keep them separate in some way. These startup APIs, based on the build flags you have that we have in OMR startup, could easily have a initialize library instead of initialize runtime, which then is whatever, like we could have, because you could, as GC Builder comes along, you could easily just have a GC Builder library now, when we get there, which I think is very similar. So you could just, like, these things that are standalone, I think we could sort of have just an API in there that you could go and invoke, which then hides this fact of bringing up the port library or any other thing you depend on away from it. Like, that's the point of this startup API or whatever we're going to call this module now, is just to sort of give you these APIs you can call. You're free to call whichever ones you want.
Yeah, I like that idea, Charlie, actually, because I mean, I think that I like the fact that you have one central place to go to do the initialization, right? You don't have to think, like, if it's just behind an API, and you can make the implementation of that as small as you can, right? So that JIT Builder could potentially, if it wants to use this, it can actually link this thing in. Maybe it's only a few kilobytes, right? So maybe it isn't a huge footprint impact to that, but it's one place you go to do the initialization.
Yeah, and like based on your build flags, those APIs are there or not there. We could have them disappear for you if you haven't compiled anything else in. If you just say, I want just library APIs and I've only got JIT Builder, well, then you only get the JIT Builder startup API. If that makes it easier for people and kind of gets rid of some confusion, which I believe it probably would.
I'm perfectly happy for initialized JIT to just be a wrapper around something else that gets pulled deeper in OMR that just does the right things.
So my concern with having initialized JIT wrap VM startup is that if JIT Builder ever became a library that was installed on a system, and GC Builder was also a library that may or may not be installed on a system, then what does, like, you no longer can rely on build flags to tell what you're bringing up. It just sort of depends on the application. So everything has to be brought up separately anyways.
Or find the one that's already up.
Yeah.
That's the real problem.
So why not, what about if we just took, like, we had either one static copy of the port library structure that was somewhere, and then everything just sort of lazily initialized it if it needed it? So like sort of enforce the notion of one global copy.
One per address space, no multi-VM per address space, no multi-JIT per address space.
Well, yeah. But I mean, the port library, as long as we have proper locking around it, it could be, you would have one port library per address space, but multiple JITs and multiple collectors. But then they would all be sharing, like if you were to change a function pointer in the table, then that would affect everything in your process. But do we actually do that?
In some places, yes. You might want a runtime to be using memcheck, which then goes and changes a bunch of the port library functions for memory so that we can do extra memcheck work. And you might not want that runtime overhead on some of the other port libraries that are being used.
Okay. Well, what about if we just had something where it was like one JIT, initialized JIT that took a port library pointer and one that didn't, and the one that doesn't just brings up its own. So you have your choice.
Yeah, I actually did that and it worked well.
So, or yeah, like a factory object where you can either tell it to use a particular port library, or when it goes to bring up the JIT, it just brings up its own. So sort of like by default it'll use its own thing unless you tell it otherwise.
As long as if you call the wrong one and it decides to create a new one,
yeah,
that doesn't hose anyone else who's already created a new one. And so if there's two, there has to be some clear behavior on what happens when you have two.
Yeah.
And it could be that you should think about making the port library initializable as many times as you like, and everyone thinks they get one, but the code's shared and the Like an attach almost.
Yeah, so you can actually bring up multiple copies of the port library table, but there's some initialization.
What does it, yeah.
Like thread local storage keys, those are shared.
Yes.
Yeah.
Okay.
So yeah, it is tricky.
I know I've been able to bring up JIT Builder just by plugging in initialized JIT into the startup and shutdown APIs. That's how I run most of my builds, just because I'm lazy and I like one API.
Mm.
So it kind of already works.
Yeah, well, so what happens so where do you initialize port library now in the JIT Builder? Oh, it's very nice.
It's not anywhere, so
No,
it's not a deal.
Not you, I'm asking the room, sorry.
So let Z answer that because he did the work.
Yeah, so right now it's not initialized and we're deciding on
I
where
see.
exactly to initialize it. So startup library already initializes it, like your startup VM. So we could, if we had JIT Builder being initialized from there, it can pass the port library that was initialized instead of the compiler initializing its own.
Right. So that makes it part of your OMR build. You'd have to have a flag that says include a JIT Builder, and it would then call it some
Or potentially
compile.
A different compiler component that somebody else had created, a different distribution of the compiler. I know that at least in, like the Java compiler, if you want to do startup that brings up the Java compiler.
Right. So you're trying to separate the JIT compiler as a basic thing versus a VM compiler, which is maybe language specific. And for example, I know where you're going. I think you have a future view of a VM builder that generates your interpreter, generates your JIT from some sort of metadata, and then that's the one you want installed as your JIT. And then the underlying JIT builder is just libraries that it was calling to implement that thing. And so you don't want it, from what I can tell, you don't want it hard-coded as a JIT builder initializer when you really think that eventually it'll be a VM builder, VM plus JIT builder monolith. I don't want to call it monolith, it sounds like an insult, but
monolith,
a combined VM plus JIT builder, like the classic Java VM or any of the other VMs we have, has all those components coming together, and the underlying thing is really the bare bones code gen.
Yep.
You're trying to reserve yourself a place for that, I think.
Yeah, a little bit. I think it's even more like...
Well, you see as a need.
Yeah. Yeah.
Do we see any hope of OpenJ9 ever using this startup? It's completely separate right now, is it not?
True, but I mean, like, do we see any, like, established language ever using this API? Because those are the people we're targeting, right? Real languages. So, in theory, we are targeting Java.
They need the bolt-on style. They add this, it initializes everything you need. Here's the new APIs that are now going to be callable because you have the right parameters to start passing them, the ends and the VMs, and JIT Builder is, I guess, there's no environment you have to pass it. It just works. It must be hidden underneath. I don't know. Can I JIT initialize in two different threads at the moment? Get two different things running?
Yeah.
Okay, so you
thread local. It probably gets unified under the statics.
So there might be things that are not separable, but I can still get two. Okay.
So at least in
multi-threading is not a well thought of thing.
In ALM, the approach that I took was to split startup into 3 tiers, which was process-wide startup, runtime or like VM startup, so not runtime, VM startup, and then VM thread startup. So, and it happened in those 3 orders. So a VM attaches to the process, and then the thread attaches to the VM. And that, in my experience, is the kind of API that real languages need to be integrated, because that's the order that it happens in. So maybe we can split VM startup into 3 tiers of APIs. One for process-wide, which would bring up port library and thread library, which is how I have it working right now. One for VM startup, which in my case brings up the GC, and then one for the thread local context, which brings up the GC environment and the mutator model. and maybe JITbuilder can somehow sort of slot into that kind of framework.
Right. Okay. So that last one brings up the GC threads, and they attach to the existing stuff you have running, and that's done there. Why? Because you're doing multiple. You're instantiating multiple ones or something.
Yeah. Yeah.
So you're saying that you have common VM pattern would be to have threads do things, and you're going to fork one, and the first thing it's going to do is go attach to the thing it's going to want to run, get enough stuff to be able to do the things it wants to do, and you have to make that work in a life cycle because threads come, threads go, and the process is going to hang around. That's not too bad.
The language runtime did kind of decide how many JT threads there are.
Oh, well, it depends.
Scenario where the runtime wants to decide.
So in the case where I have it, the number of GC threads is related to the number of cores, and the GC keeps its own threads around in its own little thread dispatching thing. So those are totally different from this model, where
So where do those get allocated? Those
get
allocated as part of the runtime?
As part of the VM.
VM?
Yeah, I guess in like the existing language that we're talking about, the runtime would be process-wide initialization, and then the VM would be like per isolate.
So threads run in a VM, which runs in a runtime.
Yeah, and there's one runtime per process, so that's process-wide state.
One runtime per process, but multiple VMs, right?
Yes.
Thank goodness.
But part of how I have this working right now is that the port library and the thread library are process-wide, not VM loadable.
I think that makes the most sense. That's kind of how we envision the APIs. If you look at some of the other OMR APIs around OMR, there's an OMR runtime, OMR VM, and OMR VM thread. We've always sort of envisioned that the OMR runtime would be your sort of process-wide, one port library, one thread library to start with, and then each VM would be sort of a VM that has a JIT, a GC, and those types of things. In the future, if like things like JIT as a service and stuff come along, JIT as a service could become part of your runtime or even outside of that again, so that you only have one, but that's all kind of future direction.
Yeah.
Okay, so what are we, not sure if there's a proposal here or not, or any sort of agreement here, is that we want to take the current initialization steps that are there and perhaps break them into multiple simplified, good conceptual integrity kind of steps. So perhaps a process-wide, perhaps a VM-wide, perhaps a thread-wide, and allow different things to happen on each of those different initialization tiers.
I think that's a great idea. I think for some runtimes, though, where they only have, if you're going to say plug into some really small runtime that doesn't have threads and things, you probably still want one sort of global thing that can do everything, but just to make that a bit simpler so they don't have to worry about starting up a runtime and then starting up their VM and then starting up their first thread for the main thread, especially if they're not going to use any of those things in their runtime themselves.
Yep.
I think we should have those three APIs, and then in the future, if we think it's valuable, wrap them all in one big one that could just sort of hide a lot of that from the user for you. But I do think the three APIs are probably the right level.
Okay, so let me ask a question about OpenJ9, because I know its initialization process is a lot more complicated than that, so I'm wondering if it slots into that model. I know it goes through a sequence of phases, and there are some dependencies between the phases and with, the order of which things are you know, you initialize all the libraries and then you can do another step on all the libraries and then, right? I'm wondering if that, like,
the way OpenJ9 does things is kind of backwards, that we all wish could change. I'm not sure OpenJ9 would ever consume these APIs.
yeah, that's not what I'm asking though. I guess what I'm trying to ask is, could we accomplish the same thing that OpenJ9 accomplishes with the same structure of, like, is there something that OpenJ9 fundamentally needed to do that was different that wouldn't fit into this model, since it's kind of our best example of an OMR-based runtime right now?
I'm not sure what you mean by fit into this model if we don't ever expect it to consume the APIs.
You're asking whether or not you could, even not that you would, but if you could implement.
Right. So I guess I'm asking: is this nice, simple conceptual model, is it too simple? Is what I'm trying to get at. Right?
I
Does
don't think so.
OpenJ9 have to do all of those complex things in order to make it work? Or, you know, if someone were to step back and spend a year and a half, would they be able to reconstruct the OpenJ9 initialization process in this more simpler form?
Yes. I've looked into it a lot with other folks. I believe it's completely possible. Because the reason right now why we do that whole iteration over the libraries is because you need to bring up this part of this component first, then part of this component, then part of that component. If we actually just had this API that called low-level component 1 startup, low-level component 2 startup, in the right order, and then for the runtime part, and then for the VM part, I think it all works. And I looked at moving a bunch, but it's, like you said, probably a large work item that I just don't have time to go do. But I believe it all fits into this model of the runtime VM and thread startup.
Okay, so we never believe that any two components are going to have a sort of circular dependency. Like, I depend on you and you depend on me, just at different times. I believe that's why
you would have to have different APIs to call to do those different things. Like, if you wanted the heap to be brought up before you brought up the JIT, then you call them in that order, and then the GC would start up because it has to be after the heap startup. Or the collector, I guess I should say GC.
I mean, there may be some circular dependencies, but that doesn't mean that we couldn't re-architect it to break them.
I'm just trying to understand, like, so for a consuming runtime that wants to initialize these things, they're going to call the APIs in that order. I guess at this point it's up to us to put everything into that kind of VM level. Like, that's the one that would coordinate all the dependencies between the various components.
So how does...
I guess so each of these components is specialized in some sense, right? Like, there's glue on the GC, there's glue on the JIT,
glue on RAS.
Glue on RAS, glue on everything, really. Glue on port thread, for that matter. But I guess, so anyway, I guess I'm not, I just have this vague concern that OpenJ9 went down this, found the need to go down this path of sequencing things in weird ways, which we're not, I don't think, intending to do inside that VM initialization step, and that forces the model on the glue.
I sort of think we are saying that, though. In that API, in that VM startup API, we're going to specifically lay out API calls to the particular components pretty much in the same order that wacky pattern happens in J9.
All right. So we're just coordinating.
Because those components have to be brought up in that way, otherwise they won't work, because that's just how they have to be brought up.
All right. So this simple model on the face of it from an initialization API actually turns into a more complicated story when you start thinking about the glue logic that people are writing to include their own GORP into that initialization sequence, right?
Maybe.
I know ideally not, but
I think most of it is these APIs are hiding that really complicated logic from you and sort of making it not a concern for you.
no, I understand it from the, as I want to initialize things, so I initialize the runtime, then I initialize the VM and attach it, then I initialize the threads and attach them. That's very simple and easy. But if I'm writing an implementation and I need to make modifications in the GC, and I need to make modifications in the compiler, and I need to make modifications in the RAS components to talk to my language to do the things that my language does, then I also need to understand the sequencing of things that's going to happen inside initialized VM, for example, in order to make sure that I'm, like, when I get called as part of the glue for this piece of the API, I know what's happened before and what hasn't happened yet, so that I can instruct do my initialization properly. Am I speaking clearly enough?
No, that's fine. It makes sense for places that are going to have that sort of decision in the runtime. I'm having difficulty coming up with a solution thinking, sorry, a place on the GC where that's a thing, but I'd have to dig through. I bet there is.
Maybe I'm imagining a problem that doesn't exist.
I think startup's hard. So I think it's realistic that we're going to sort of approach a runtime that does do startup in a complicated circular way, and then there's a possibility that this API is simply just not going to fit into their model. And I might argue that their model is bad and they are bad programmers, but that's not really going to get us integrated into their runtime. So I think maybe really the best thing that we can do is have like a clear statement about the dependencies between our different modules, and possibly like a diagram, but as well have that clearly expressed in our startup APIs. So if JIT Builder needs a port library, then that should be one of the parameters in JIT Builder Startup, so people can see that that needs to come up first. And then, we can layer helpers on top of this, but at the core, we just need like a dead, simple, obvious model for how the dependencies all plug together.
I'm not speaking against that. I believe that's true.
Yeah.
I guess I'm saying I think we also need to document deeper.
I think as well, if we're going to kind of take a model like this, we may find that we're breaking up OMR components into finer-grained modules. Like maybe suddenly there's a base GC module and then a secondary GC module that gets initialized later. Different. Something like that. I think that's, if we go down this path, we might something like that. But,
we have legit sprinkled through various places too.
Yeah.
Yeah. I don't know. I think you have to understand the reasons that were in place because of that. Because I think sometimes some of those decisions, those architectural decisions, were made because they were easy rather than doing the right thing.
Maybe. But a lot of it's just the way it ended up. Right? It's been around for 20 years. We didn't always think hard about things before we did them.
Yeah.
All right. So the evil question: how does option processing work inside this? So how do you configure this startup process?
I have an opinion on this.
Okay.
So I think that in my mind, I think that the simplest thing to do would be to have some sort of like configuration that's programmably accessible. So a language would say things like, these are my heap bounds, or this is my maximum heap size, or whatever. Or in JIT, like I want inlining depth of whatever. Or and then we have built-in helpers that an application can optionally use to initialize defaults. And those helpers might do things like read from like the command line or read from environment variables. But they're totally opt-in, and they just initialize the structure. The and the language is fully capable of initializing that structure itself. And then when we go to startup, we go through like a validation pass where we make sure that the options make sense, and if they don't, then we crash or whatever, fail to start up, and if it works, then it works. And then we just sort of have a bunch of different like fine-grained configuration structs for each component.
That's sort of quite similar to what I'm going down the path of right now for the GC. Option parsing, I really feel, is up to the runtime itself. Lots of runtimes have funky ways they want to do things, and a lot of them already have that. But we sort of do need a generic sort of configuration thing. So for the GC, I was thinking about adding a helper that goes and gets you this struct that has a bunch of default values in it for what we believe might be good GC options, and then based on your own command line processing, you can set these fields to whatever values. Then when we go to bring up the GC, we validate them that they make sense, and then report any errors and fail to start up if there's anything that we can't start up. But if they all work, then we just continue forward and start up. So it would be one of the things that would be hung off of the OMR VM, for a lack of a better place. It would just be like GC initialization parameters or something.
I would probably copy it into the extensions or something. I think that's how I would do it.
Well, I actually would have it in extensions, and you would fetch extensions from OMR VM, but yes, I agree.
And then the other thing is, if we structure our APIs right, if the application doesn't provide a configuration for a component, it somehow sort of defaults to something.
Yeah, so the right APIs could just do the right thing.
Yeah. So
how do I get options from the environment? I haven't set up my port library yet.
So I think
that's a good question.
I'm still stuck on the first thing that happened before.
Right. I think that what we would want to do is to if we're going to actually define the order, like the minimal Big Bang kind of thing that needs to happen for all this technology. Like maybe the port library has to be the first thing. The Fred library for port library has to be the first thing to get initialized. Some very basic data structures.
But I guess the question is, does the port library have any configuration options of its own, or is it just port library doesn't get any options?
It does have options, I think, for tracing.
There are some options for the port library. Very minimal, but there are some.
From the command line, or?
Well, no, because there's no command line parsing, so.
Yeah. But the port library does do tracing, I think, and the tracing engine needs to be configured, which probably needs the port library, so I don't really know how that works.
Port library startup and shutdown don't really, if there's trace points in those are a waste, because they don't actually have a chance to run, because you need the port library for the trace engine.
Okay. Well, maybe I should just validate that assumption that the port library does have trace points. But yeah, okay.
But definitely are trace points in there. I don't actually think we should have them there, but that's a different architectural discussion completely than this one.
Yeah.
It would be useful to have a consistent model across the entire OMR of how we actually handle options, how we do things, because I think, like reading right now, the compiler technology and the rest of OMR are different for sure.
But are you talking command line options or the way we configure the component?
Both.
Well, see, I don't think command line options are a thing for OMR. I feel those are a runtime thing. I think components need a way to be configured, some structure that has values in it. But if you want...
I think Daryl's statement was just a statement of where we are right now, as opposed to where he thinks we should be.
Yeah. And actually, I don't I think that there might even be an opportunity to provide some kind of elementary processing that a language runtime might want to use for parsing command lines and things like that. Like if you don't already have something like that in your runtime, perhaps you need a tool in the box that'll get that for you. So that could be an opportunity for us to provide that.
I agree.
Yeah, but as opt-in, right?
Yeah, absolutely. Yeah.
And it's a piece of the utility part of OMR I believe you could use, but what the option is versus what it sets, I still believe is something the runtime should decide. So we provide some facility for parsing command line options and setting a value, but what that option is and which value gets set, I still believe belongs on the runtime.
Oh, I see. So you want sort of like a generic command line interface library.
Here's how you parse things from the command line. Here's how you pull values out of environment variables, the different ways that we could have things. Here's an options file that you could pull things out of, define those things generically. But X, foo, something, that is your runtime in my opinion. But I could be convinced otherwise if we want some generic ones. But
I guess the question is, do you want to always live in a world where different runtimes have different command line options, or do you want to try to influence an OMR ecosystem where there's some commonality in how command line options are expressed?
I would love to see people consuming OMR be consistent, so that I could say, here's the OMR GC options that I would like to see used.
Right. So I think that lends us to, we'd like to have a preferred implementation of how you could manage command line options, but then there's another way in where you can just provide this struct, and if you want to, you have an existing runtime, you run your command line options the way you already run them. So, if you want to keep that model, then here's how you can, kind of stick stuff in to configure OMR according to how you want to express these options. Which I think what Robert's saying is, it makes sense to me that the lower level piece is like all of the OMR componentry is all driven by a struct that has a bunch of flags and strings and things inside it that configure it. And there's sort of other services built on top of that to try to have different ways of getting those structs created and set up.
Yeah.
Makes sense to me. Anyway.
Okay.
Yeah, I want to make sure that we don't derive the set of options based on any one consumer to be the style of options we use.
Well, that's why we get the freedom to change, to build our own preferred model, right?
Mm-hmm.
But we do still have to, so for the JIT, I don't know about the GC, the option processing that's currently in OMR is kind of a subset of or most of the J9 processing options are there. Which we need to preserve those for J9, but that doesn't mean we can't also try to create a different way of specifying those options.
Yeah, GC doesn't really have any option processing in OMR.
Oh, really? Not even for stuff like that. So
there's an environment variable where you can configure a few small things, but we didn't move our options over. Those stayed on the Java side where they belonged.
Interesting.
The type of options that were there. Not saying that there aren't GC options that belong at OMR, but a large portion of the ones were very Java specific, in my opinion. So they didn't move over.
The only thing that's Java or J9 specific about the JIT options processing is that it starts with -JIT, right?
Yeah.
Or I guess the method signature parsing is also Java specific, obviously.
Mm-hmm.
But the notion of the options, most of them are generally useful kind of things. They're not necessarily obviously some of them are language specific, but a bunch of them are not. Right, like setting the invocation count, I guess. That's done in J9. But setting an off level, for example.
Yeah. To me,
I think
if we start to do this, then I think that the option parsing starts to have a very large runtime set of app code. And I'm going to start using app code instead of glue because I think Rob actually made a valid point. That's a better name. Or application extensions or something. I think that's where we'll see a huge amount of growth would be on your runtime having some ability to go in and set those options. But if we start to do this, then I think the location those options get set. So if we do this, I think option parsing that we have should come down to one set of API and not like OpenJ9 where every component sort of does it on its own.
Yeah, agreed.
Which means then we start to have one global location where values get set. In my opinion, if it's going to be like that common. So
unless our options go into a hash table, I don't really know how we could combine options together fluidly. Does that make sense? Like because I mean, if a person's just bringing up GC options, does it make sense to also be parsing JIT options?
Well,
and maybe from the VM API it does.
So they'd be compiled out due to the build flags.
So one thing that's unique, and actually it's a really good story for the compiler technology that we have right now, is that the command line options are actually can be per method as well. It's not just these are global option settings. They actually do apply for methods or patterns of method signatures, and that's a really good differentiator with this. Well, with the Java technology versus, let's say, something like Hotspot, which doesn't do that. So we want to make sure that, you know, if you have a table kind of approach, hash table, you have to be able to specialize that by method filter of some sort. Yeah. So.
And the filter can be wildcard.
Yeah, it's a regex, right?
I mean, the other thing is
we don't have a hash table right now.
The other thing they don't want us to forget is that there are multiple VMs per process and only one set of command line options and only one environment. So how does that work? These are the defaults that a language would then be able to override on a per VM basis. So I think that the language has this, should be the thing that sort of glues together VM initialization and command line option parsing. But as well, you know, we can still provide our own defaults if we want to.
I guess that's another question. Is that all just static? You set these things at the beginning and they're like that forever, or can they be changed dynamically?
Some things can be changed, and we support that in a lot of the components of, like, if you look at something like OpenJ9, you have the MX beans, which can control a lot of features and stuff.
Right.
And those give you the option to change things that are allowed to be changed at runtime.
Right. So to me, that means some of this config should probably be at the runtime. Sorry,
some of it should be at the runtime level because it's command line-ish. There's only one command line per process. Some of it probably needs to be at the VM level because you may want one VM to be able to override a setting and not have it affect other VMs.
Yeah, I think so. That was sort of why I was breaking it down, as you got this structure that you could fill stuff in.
Yeah.
And then you pass that to the runtime on startup, the VM on startup of the VM, and then the VM sort of does what it needs to with those options. Because two VMs, if we're talking really crazy, could actually, one could reject a set of options and the other based on how it was configured or compiled, if we were going to say we have multi-VMs here in the same runtime, also use that set of options and be successful.
Yep.
From the command line. That's kind of crazy. I don't know if we'd get to that point anytime soon, but I think that is an option. So,
at least in the case of testing, there's no way that options are going to be coming from the command line at all. Not a single option will come from there. So, and then again, that also means that it's impossible to have process-wide options because you're going to want to bring up and tear down things under different configurations in the same process. So I don't know. Yeah, I think it makes sense that like configuration validation happens at like the smallest granularity. Or
That's why I think we should probably work inside out on this. Define some way for the components to have a, or sorry, not components, the VM to sort of have VM initialization. Do what we need to get that set up and have some sort of common infrastructure that works for all components. And then once we have that, if we want to go and start doing things like command line processing and things for the process, then we can build upon it at that point.
That makes sense.
Which I think we will do, but I think we just need to sort of build it inside out here.
Mm-hmm. Potentially complicated JIT options to fit into that, like the model being able to specify options under an optional set, for example.
Because I've sort of been poking at defining this for the GC right now, and being able to control even the ability for things to change at runtime. So by sort of having a set option blah, value blah, and I actually have a reason why you're setting it, because actually that comes in quite useful. And the reason is command line option, environment variable, default, runtime decision, sort of different information along those lines. I want to make sure I don't complicate things too much or make it slow down startup in any way, but I think it's a good way for us to start sort of defining these things.
Okay, cool. So I think that the options processing I think is a whole other thing that we can be discussing. I think back to maybe the very original question that you were asking about options processing was sort of where does it fit into the overall initialization scheme, and I think that the consensus seems to be that we can do it very early on. Okay, so I guess we're a few minutes past the top of the hour, and are there any other thoughts on the initialization problem that we had talked about that anybody wants to bring up? So what I'm going to do is sort of summarize our discussion here and put that into an issue that we can continue the discussion on if necessary. But I think that there are some follow-up work here to to break the API up and to start fleshing things out that way. So, any other thoughts anybody wants to bring up right now? If not, thank you everyone for joining, and we'll talk again in a couple of weeks. Okay. Thanks everyone.
Thanks. Bye.
Bye.